Okay, everybody, we're going to finish up section 1.2 today, and therefore chapter 1, which is great. So we're going to be finishing up with the last few objectives on this, and should be kind of fun. Okay, here we go. So we're starting with this idea of computing the standard deviation. So we're going to start off with the concept of what is the average deviation from the mean of these numbers. So what I've done here to make this a little faster is I've put in this data into my list 1 of my calculator so we can kind of play with it. So the first thing we should ask is what is the average distance? Okay, so from the mean. So we first of all have to find the mean of the data. So I'm going to go into Wabbit. I'm going to go stat, edit, stat, calc, one variable statistics, and I want to choose list 1. Okay, and calculate. Okay, so I get that my average is about 5.5, and I'm just going to round. Typically, I want to stay at about 3 decimal places, but for the purpose of this exercise, because I'm going to be doing a lot of writing, I'm going to leave the mean at 5.5. Okay. All right. So I want the average distance from the average. So what I'm going to do here is I'm going to say, well, distance is basically if I take the number, a value, minus the mean, I'm going to get the distance, right? So here's what I'll do. This column will be the value minus the mean. So 3 minus 5.5. Okay. 5 minus, and what's cool about this is now I can set this up in the calculator, right? The average, or sorry, the distance from the mean. So I go, okay, stat, edit. So list 1 has my data. List 2 I'm going to make be that difference. So I'm going to have that be list 1 minus 5 point, I'll use as many decimals as I can fit in here, 5, okay, like that. All right, there we go. Good, so now list 2 is the distance from the mean. Okay, so I'm looking here for a sense of how far away from the average are all my data. Good, so now I want to take the average distance from that. So these are the distances. Okay, we have negative distances and positive distances, and I'm going to take the average distance from the mean so that I get a sense of how far away most of the data are. It's going to be a good measure of spread. So I'm going to go back to my home screen, and now list 2 has my distances, so I'm going to take stat calc of list 2 so I get my average distance. And I get that the average distance is 5.55 times 10 to the negative 9. Well, what does that mean? Right? That's basically the point.
Please pardon this interruption. Is a driver of the limb
1, 2, 3.
Please come out and move your vehicle.
6.
We have a trash pickup today. Can you come down and move your vehicle? Thank you.
Okay. All right. So interruptions happen all the time. So they're saying that the average distance from 5.5 is pretty much 0. Actually, that's so close to 0. It up to round off error really is 0. So the average distance, all these here is what they're saying, is the average distance from 5.5 of these numbers is 0. Now, we know that's not right, okay? So we have to figure out what we're going to do to fix that, okay? So what happened here was, oh, that's not the one I want. What happened here is that we calculated the average distance from the mean, okay, the mean of 5.55, but we took into account negative distances and positive distances. All right, now it's a nice idea, except that what happened was when we averaged those together, they offset and we got 0. Okay, so if I do this, I should get exactly 0, but because of round off error, I got something a little bit different. So instead of doing the average distance from the average quite like that, I'm going to take these and I want to make them positive. Okay, so I've got a couple options here. Now, the most obvious one is to take the absolute value. Okay, and I go to find the absolute value. I think it's in here, isn't it? No, there it is, absolute value. I could take the absolute value of list 2 and now take the average of those. Now, there's nothing terribly wrong with that. It's just not what we do in statistics. And there's a couple reasons we don't do this in statistics. The main reason is that the absolute value function is a kind of an ugly function, right? If you remember from Algebra 2, right, it's a function that comes down to a point. And we call it point of cusp in calculus. And that's a really ugly function to have to deal with. Okay, so instead of doing that, in order to make the function more differentiable and a little bit prettier to deal with, instead of doing that, typically what we do is instead of taking the absolute value, we square the differences. Okay, so I'm going to take L2. I'm going to square them. So if we, I mean, those are our values. So we come over here, okay, and what we're doing now, these are dot, 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 is we take the value minus the mean, square them to make it positive, okay? Because a squared function, remember a parabola, if you had to decide which one to use, a parabola or an absolute value function, you'd almost always choose the parabola, the quadratic, okay? So instead of taking absolute values here to make them positive, we take the squares. So this is 3 minus 5.5 squared, 5 minus 5.5 squared, and so on, okay? And what we get there is these values here. So 3 minus 5.55 is going to, or rather 5.55 minus 3 is going to be negative 2.556, squared, to make it positive, 6.5. 5.55 minus 5 is negative 0.555, squared is 0.30864, and so on. So L3 now, if I scroll through these, I see L3 is my list of squared values. Now I'm going to average those. Okay, so I go back to second mode, stat, calc, one variable statistics. Now my squares are in list 3, so I go list 3. Good. Now that's our average. Okay, so the sum of the squared differences was 34. So the average, and I don't know, let's see here, do the average equals 34, what was it, point something, 34.469. And again, in general in this class, we always want to keep 3 decimal places, at least, if not 4 decimal places. 34.469. Okay. So it's saying the average distance from the average now, so the average distance from 5.5, from this value here, of these numbers is a distance of 34.469. Again, that's not quite right, right? If I start at 5.55 and I add 34, okay, or subtract 34, 34 is way outside of the data range. Okay, that's an enormous number. So the average distance from 5.5 is not 34. And what happened here? Well, 34.469 is the average of the squared values, the squared distances. So if I want to undo a square, I take a square root. Okay, so I'll come up here and I'll take the square root. So 34.469, the second square, 34.469, boom, 5.87. Now this is a pretty reasonable distance. What we're saying is that in some sense, the average distance from 5.5, from the average, is about 5.87. Is it reasonable to say that most of the data in here are within a range of, and again, I'm using these terms very loosely, 5.55 plus that value? Okay, now that's about right. Or 5.55 minus 5.871. Yeah, for the most part, most of the data fall in a range of negative 0.3115 and 11.426. So that's a pretty reasonable estimate of how far away from the average most of the data in this data set are. Okay, so that's kind of the intuitive buildup. And here's what we look at. The first number that we got, the average of the squared distances, is called the variance, and it's denoted by s squared. Okay? It can be written this way, where I take the distance squared plus the distance squared plus all the way up, or I can write it this way, okay? Which is just the same thing, but it's using the sigma summation notation. All right. Now, before I go on and I talk about that, you're no doubt saying, well, Mr. Null, this is not an average. There are n of these numbers, okay? But it says to divide by n minus 1, okay? Now, I don't want to take time explaining why this is the case, but in general, this is what we do when we talk about the variance, okay? We divide not by how many we have, but how many we have minus 1. Okay, so in the previous example, it's not really an average I'm looking for, actually. There are 9 datum here. So the number that I got, 34.469, I got by adding up the square distances and dividing by 9. I really, according to the formula I have, I really should divide it by 8. All right, I'll explain that a little bit more a little bit later. So the variance is the squared number, and the standard deviation, this should not have a square on it here, it's a typo. The standard deviation is a plain old S, okay? And that's what happens when I take the square root of the variance, okay? Both the numbers are very important, okay? But the variance is in squared units and the standard deviation is in regular units. The number at the bottom is just the sample size minus 1, okay? We call that degrees of freedom. That number and that term will come up again, okay?